time! It's factoring boot camp time, soldier! Everybody loves to factor, don't they? It's boot camp! Factoring boot camp! Woo! Can you factor? Factoring boot camp, baby. It's one of the F words you're allowed to use in my classroom. I don't know about yours. All of our information can be found at www.nkinfinity.com. By the way, we're working on this website. By the time you're here, it'll probably be up and running. I don't even know where it is. Not that page. I'm uploading videos there. Nope. NK, boom, done. There it is. Here you'll be able to see my partner in crime, Miss Vicki Newman. A little introduction video for teachers. I know it says New York State teachers, kids, but if you go here to the lessons and you're working on unit, well, I don't have 3, 4 working on unit 3 right now, aren't we? Unit 2 is done. If you go down there, click on Unit 2, there are all of your videos. I got to change these things. I don't like these. I'll change that eventually. These will probably be darker red when you look at them. They'll look like this. They'll look a little bit better. At any rate, take a look. There we are. You'll be able to just say, hey, I don't know how to do it. Ooh, look at that. We had a radicals party. Party time. All right. Let's get going. Don't need that. We need this. Let's get going. We are in factory boot camp. Soldier. By the way, I was in the military, if you're wondering. Yes, I was in the Army for a little over 4 years. Met my wife there. Had a good time in Deutschland. Ooh, Deutschland. So, multiplying by polynomials and factoring polynomials are inverse operations. They just kind of undo each other. So, this is a monomial, -5, times a binomial. We just distribute. That's -20. -5 times -6 is +30. N. That's it. Well, that's distributing or multiplying a monomial times a polynomial or a binomial. Now, I want to factor. GCF, greatest common factor. I can't stress this enough. Star, underline, highlight, throw arrows at it. And then let's do one more highlight. GCF. Oh my gosh, it is so important that you start all factoring problems with a GCF. Please, please, please. You look at the two pieces that you're working with and you decide, is there something that they have in common? They have a 3 in common and they have an X in common. So what we're going to do is we're going to put a pair of parentheses. Anytime you factor out a GCF, it's one set of parentheses. You're going to put a 3x out front. Now, if you take the 3 away and you take 1x away, you're left with x. If you take the 6 away, or 3 away from the 6, you're left with 2. Remember, you're dividing it out. 2. So minus 2, and you took the x out, it's gone. There it is. You should be able to redistribute and get the same thing. 3x squared minus 6x. And it should get back to the original. All right. So we're going to work on factoring and then distributing. And someone's got their hand up in the back of the classroom. Yes. Yeah. Taylor. No, the other Taylor. No, the other Taylor. No, not. I had a class one year with 4 Taylors in it. 4 Taylors. What? That's crazy. But anyway, you're probably saying to yourself, didn't we learn this in 9th grade? Absolutely. That's why today is going to be a little bit of me just plowing through some problems and then you spending a boatload of time working with a partner in class. Okay? And I'm not going to do the partner problems. I'm just doing these problems. Distribute. 3 times 6, 18C. 3 times 3D, plus 9D. Factor. What do they have in common? They have something in common, so one set of parentheses. And I'm going to put that plus sign right there. Immediately I put that plus sign there. Because if I start with a binomial and I'm taking out a GCF, I have to end with a binomial. And that's going to become important when I do some other problems later on. You'll see what I'm talking about when we get to problem 6. So I take out a 2, and I'm left with We'll take out the 2, take out a 2. I'm left with a plus b. Catching. Distribute. By the way, if you already think you know these, try them on your own. Pause. Try them on your own. See how you do. Negative 8n. Negative 12n. Now don't forget, when we multiply, we add the exponents. And there's a 1 right here. So this is n cubed. What do they have in common? They have an x in common. So as soon as I know I'm going to factor, I put down, it starts with a binomial. I have to have a binomial inside the parentheses when I finish. They have a x in common. When I take the x away from there, I get left with 2. And when I take an x away from there, I'm left with x. Catching! By the way, if I make a mistake because I'm going too fast, someone email me and let me know. 10 times 2 is 20x. 10 times a fifth. Oh my God! Fractions! They're so scary. They're so scary. Multiplying by the fifth is the same as dividing by 5. So it's minus 2y. All right. Let's take a look at this one. I might want to blow this one up. Blow it up. Blow it up. Maybe I want to blow them all up. I think that's as much as I go. All right, so we're going to take a look at this one right here. Now, I'll tell you why in a second. I'm going to go, they have a 2 in common. So I know I'm going to take a GCF. As soon as I know I'm going to take a GCF, I'm going to write down one set of parentheses, and whatever signs are in there, I'm going to copy over. Now notice I started with a trinomial here. That's 3 terms. I better have a trinomial in those parentheses. You'll see why I'm making a big point about this in just a second. So they all have a 2 in common. They also have a c in common. So I'm going to take out a 2c. Now let's see what's left over. When I take a 2 and 1c away from this, I'm left with c squared. When I take a 2 away from this, remember you're dividing it out. You're taking a 2, and you're going to divide out a c. I'm left with 2c. When I take a 2 out and a c out, whoa, 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 nothing. Now, lots of kids forget this. Please, 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 please don't forget this. Just because you took all of it out doesn't mean you can't end up with a trinomial. You have to have a number here. You have to have something there. And remember, you're really dividing it out. You're dividing it out. So when you take out that GCF, you're dividing this by 2c, and you end up with 1. Now, again, remember, I should be able to redistribute and get back what I started with. 2c times c squared is 2c, add the exponents, remember there's a 1 here, plus 2c times 2c is 4c squared, remember there's a 1 here too, and then 2c times 1 is just plus 2c. So remember, the key is if you started with a trinomial, this was a trinomial, you got to end with a trinomial. All right? Don't forget that. Let's distribute. 5d times d squared is 5d, add the exponents cubed. 5d times negative 3 is negative 15d squared. Whoa, what do they have in common? Well, 7 goes into 56. So I know I have a 7 in common. As soon as I know I have a GCF, I'm going to copy this down. I have a binomial. I better end with a binomial. Don't forget that, kiddies. I know I'm taking out a 7. They also have an a in common, and they also have a b in common. So I can take out a 7, a, and a b. So I take out the 7, I take out the a, I take out the b. Nothing's left. Not nothing. Remember, you're dividing out the common factor. So you're dividing out that 7ab, there's a 1. So when all else fails and everything's gone, put a 1. Don't say, oh, there's a Krause, there's like nothing left, so nothing. I'll put a 1. Put a 1. 7 times 8 is 56. We took out an a and we took out one b. So b to the 4th. How you guys doing so far? All right. Let's turn the page. All right, let's keep moving on. What do we got? What do we got? Come on now. Why are you being annoying? So, factoring trinomials. I'm telling you right now, if you're in my class, if you're not in my class, you're not going to know this. But if you're in my class, you're going to know I love to factor. So when you're multiplying binomials, let's pretend this wasn't here. Let's just pretend this wasn't here. I'm going to get rid of it. Well, if I just had this, I'd say, oh, distribute. Negative 3 times that. That would give me negative 3x. And negative 3 times that. Oh, that would give me negative 24. And I'd be done. That's not what I have. Let's pretend I didn't have this. And I just had this x, and it was really right outside this parentheses. I distribute. I get x squared. And then I get plus 8x. But that's not what you have. What you have is both. You have both sitting there. So that's why we call it double distributing. Now, some of your teachers might call this FOIL. That's an old acronym acronym used. For some reason that doesn't sound right. But whatever. We're gonna double distribute. So we're gonna multiply x times both of these. X times x, x squared. X times 8 plus 8x. Negative 3 times x, negative 3x, negative 3 times 8, negative 24. Now, there's almost always a little bit of cleanup work. By cleanup work, I mean you got to simplify common factors. And since these are common factors, they need to be simplified. So your answer is x squared plus 5x minus 24. Now, this should come as no surprise to you because you've done it already before. So this should come as no surprise to you that this is the answer. So factoring, we're going to use sum and product. So here's how this works. You need to find two numbers that add up or sum to negative 7. But when you multiply them, they have to multiply or have a product of positive 12. Now, if you think about it, in order to get a positive, I need to multiply a positive times a positive to get something that's positive. Or I can multiply a negative times a negative to get something positive. When you add these two things up, isn't their sum going to be positive? When you add these two things, isn't their sum, when you add them up, going to be negative? Well, that should help you when you're deciding on things. I know that when I factor this sucker, they've got to, x goes here and x goes here. They've got to sum to a negative, but add up to a positive. So I could choose 3 and 4. Those multiply to 12, but when I add them up, they give me negative. They give me positive 7. I want negative 7. So when I multiply negative 4 times negative 3, I get positive 12. And when I add them, I get negative 7. So I want negative 3 and negative 4. So we are going to double distribute here. We're going to multiply d times d, we get d squared. We're going to multiply d times negative 6, and we get negative 6d. We're going to multiply negative 5 times d, we get negative 5d. And negative 5 times negative 6 is positive 36. Oh, excuse me, positive 30. All right, we're almost done. These combined will give me negative 11. So I end up with d squared minus 11d plus 30. Now I'm going to show you a method called the product sum method that many teachers use in their classroom. It is not my favorite, and it is not the one I use in class, but it is certainly a good practice for when we do higher level factoring. So here's how it works. You need to find two numbers that multiply to positive 15 that add up to 8. And I hope you know that's plus 3 and plus 5. They multiply to 15, and they add up to 8. Well, if you know that, and they're easy factoring like this, you're really done. The answer is x plus 3 and x plus 5. Now, that's my favorite way to do it. It's called guess and check. You just go right there. But there is another way to go about doing it, and it helps when the factoring gets harder. It helps a lot of people when the factoring gets harder, and it's called product sum. So we'll practice it a little bit here. I'm going to do it in blue. So what you're going to do is you're going to split that middle term up. You know, like over here where I took these two and I made this one. Well, now I'm just going to work backwards, and I'm going to split it up. So I'm going to make it x squared plus 3x plus 5x plus 15. So the only thing I did was I split this up. That's it. That's all I did. So now I want to look at the first two, and I want to pull out a GCF. And then I want to look at the second two, and I want to pull out a GCF. So in this case, the GCF is x. I'm left with x times x plus 3. Copy over this sign, plus. These two have a 5 in common. That's 5's hard to see. Maybe I can get rid of that highlighting. All right, that 5's hard to see. They have a 5 in common, and I'm left with x plus 3. Now, if you look at this term, and you look at this term, what do the two things have in common? Don't worry about this up here. What do they have in common? Well, I think that you'll see that they actually have both of them have, I'm trying to get rid of this highlighting up here, but for some reason it's not going. There it is. All right. They have an x, they both have an x plus 3. And since they both have an x plus 3, that's my first set of parentheses. And I'm going to take out the GCF, and what remains is x plus 5. And that becomes my second set of parentheses, x plus 5. All right, we'll do that a few more times. Double distribute. M times m is m squared. M times negative 7 is negative 7m. 3 times m is plus 3m, and 3 times negative 7 is negative 21. We're almost done. It's m squared. These can be combined. Minus 4m minus 21. Notice there's no equal, so I'm not asking you to solve anything. So you need to come up with two ways, a way that multiplies to 7 and adds up to 10. So the two numbers are plus 2 and plus 5. Because clearly 7x is the same as those two. All I did was split it up. All right, so I'm going to combine these two, and I'm going to combine these two. I can take out a GCF. I take out an x, I'm left with x plus 2. Over here I take out a 5, I'm left with x plus 2. All right, what do they have in common? Well, they both have an x plus 2. So if I take that x plus 2 out, that becomes my first set of parentheses. I'm just taking it away from both of them. Factoring out the GCF. I'm left with x plus 5. Now, most of you are just going to say, oh, 5 times 2 is 10. Boom, done. But these in-between steps, when the problems get harder, will help many kids. Again, when we do the harder factoring, I'm going to do it two ways and give you the option. You can either do it guess and check, or you can do it by product sum. And I'll make that option available to your teachers as well as you. So let's keep moving. All right, double distribute. Z times z is z squared. Z times 8 is plus 8z minus 5z minus 40. Okay. Z squared plus 3z minus 40. Now, as you look through this process, if I worked backwards here and I took 3z and I made it into these two, I could easily factor into that thing up there. And that's just kind of what we're doing over here. So it's a little bit trickier now. because the middle term is negative. So I need two numbers that are going to add to something that's negative. All right, so that's either going to be probably 3 and 5. Wait a second, they got to multiply to be negative. If they have to multiply to be negative, one of them has to be negative. So if I made that one negative, those would add up to positive 2. So really what I want here is a positive 3 and a negative 5. Now those are your answers. Quite honestly, those are what's going to go down here. A minus 5, A plus 3. Okay. So these are what I want to replace negative 2a with. So minus 5a plus 3a minus 15. Group these two. Group these two. On these two, I can take out an a, and I'm left with a minus 5. On these two, I can take out a 3, and I'm left with a minus 5. So if I look at this thing, and I look at this thing, don't they both have an a minus 5? Sure. I'm going to factor out the GCF, a minus 5. What's left over? A plus 3, and that goes here. Two more. Dots. Dots. What's dots? I don't know. I'll tell you in a minute. X times x. X squared. X times negative 3. Negative 3x. 3 times x. Positive 3x. 3 times negative 3. Negative 9. So this gives me x squared. Now I got to combine these two. Negative 3x and plus 3x. They go away. And I get minus 9. There it is. Dots. What? Dots. All right, multiply to negative 80 and sum to 2. So I believe that is minus 8m plus 10m minus 80. What do these two have in common? They have an m in common, and I'm left with m minus 8. What do these two have in common? They have a 10 in common. I'm left with m minus 8. Again, group these together and group these together. What does this first grouping have in common? Or what do the two groups have in common? They both have an m minus 8. That's my first set of parentheses. M minus 8, gone, gone. And I'm left with m plus 10 for my second set. All right, so I'm going to give you a little sneak peek. Dots. There it is, dots. The difference of two squares. I'll be right back. Dots. The difference of two squares. It's just easy to remember. Dots. Difference of two squares, or two perfect squares. So take a look at these parentheses. What do you notice about these parentheses? Aren't they exactly the same, but the middle term's different? Later on, probably we'll call these conjugates. When you have conjugates, you have the exact same parentheses, but one's plus and one's minus. And they will give you or yield two dots, difference of two squares. Watch what we do. 2 times 2 is 4x squared. 2 times 7 is plus 14x. 2 times, oops, did that already. Negative 7 times 2 is negative 14x. And then negative 7 times positive 7 is negative 49. Well, if you've done this correctly, you have a positive 14x and a negative 14x that cancels. So you end up with 4x squared minus 49. Difference of two squares. Difference of two squares. This is a perfect square, and this is a perfect square. 4x squared is 2x times 2x. 49 is 7 times 7. So they're perfect squares. So when you factor the difference of two squares, what you're going to do is simply say, oh, okay, I'm going to bust up the perfect squares, 2x and 2x. What multiplies to 81? Oh, positive 9, negative 9. difference of two squares. All right, and sometimes they give you a complicated one like this. Square root of a plus b, square root of b, square root of a minus the square root of b. And you're like looking at it going, what is that? Well, that's the difference of perfect squares too. You know what that turns out to be? A minus b. Weird one for later. We'll talk about that later. But remember, if you do the different dots, you'll find out. We're going to do this eventually. All we're doing is factoring the difference of two squares here, okay? So that's all we're going to factor. So I know that 9 is a perfect square. I also know that 121 is a perfect square. What multiplies to 9? 3 and 3. And then z squared is just z times z. 1's plus, 1's minus. They're conjugates. What multiplies to 121? 11 times 11. Dots. Difference of two squares. What multiplies to 80 or 64? 8 times 8. And we still need the y squared, so we'll put a y and a y. What multiplies to negative 49? Plus 7 minus 7. Keep going. 25. Well, 25 is a perfect square. What multiplies to 25? Oh, 5. And don't just put 5x and 5x. I know that. Now be careful here. What multiplies to 16? Positive 4 and negative 4. A lot of kids want to put 8 there. How many of you just did? X squared is a perfect square. It's just x. It's x times x. That's a perfect square. 144 is a perfect square. 12, negative 12. One's positive, one's negative. If I'm moving too fast, pause it, go back, stop. 4 is a perfect square. So 4 is 2x times 2x. 9 is a perfect square. 3 and 3. One's plus, one's minus. Doesn't matter which one you make plus or minus. Makes no difference. Oh, this one's kind of tricky, but 36 is a perfect square. It is just 6x and 6x. 1 is a perfect square. 1 and 1. One's plus, one's minus. Over here, 81 is a perfect square. 81. What is 81? It's 9 times 9. So this is 9, and so it's 9x and 9x. That gives me 9x squared. 16 is a perfect square. 4 and 4. One's plus and one's minus. But that's not what I have here. I have 16y squared. So don't forget, you still need to include those y's there, because this is how you get minus 16y squared. Now, I kind of skipped this one. We'll go back to it. I got a little star there for you. Not perfect squares. Now, why would I put this one on here if it's not perfect squares? I mean, I'm crazy, but I'm not that crazy. And it goes back to the thing I starred, highlighted in 2 different colors, drew some arrows to it, and did a whole bunch of other crazy stuff. And that is the fact that you must check for G, C, F first. That's rule number 1. First rule of factoring, take out the GCF. So 3, and since I know I'm doing that, I better put a binomial. So take the 3 away, I'm left with a squared. And 48 divided by 3 is 16. Oh, dots. So don't forget, the 3's got to come along. A times A, 4 times 4, one's minus, one's plus. GCF. These aren't perfect squares, but I certainly can take a 5 out, and I'm left with m squared minus 36. So I'll take out a 5. Don't forget that 5's got to come for a ride. M and M. Ooh, M&Ms. I love M&Ms. One's plus, and one's minus. No GCF here, but man, this is funky. So 100 is a perfect square. X squared, perfect square. Y squared, perfect square. We've got subtraction, difference. Z squared is a perfect square. So I have the difference of 2 things, although crazy, are still perfect squares. And there is no GCF. So what multiplies to 100? 10 and 10. What multiplies to x squared? X and x. What multiplies to y squared? Y and y. So I've taken care of this piece. One's plus, one's minus, and then z and z. Well, that's it. That's just a quick refresher of 9th grade algebra or 9th grade factoring. You're going to get into some really crazy factoring later on, and I'm not going through all these problems with you. But one of the partners in class will do those problems, these 30 problems. The other partner will be doing these 30 problems. And then I want you to compare your answers. Are they the same problems? I don't know. It doesn't matter. Just compare your answers. All right, kids. That's it for basic factoring. There's going to be a lot of classwork because it's really review, but it's boot camp. It's like practice factoring. All right, kids. Catch you on the flip side, homies. Bye.